Part 2 of Section 1.7 is on the distributive property. The distributive property is used repeatedly throughout algebra. We'll see this again many times, even in Chapter 2, Chapter 4, throughout other courses that you're going to take. Okay, this says if you have an expression such as 5 times 4 plus 8, the distributive property tells us that we can distribute the 5 to each term in the parentheses. So when we have one term that's being multiplied by a set of parentheses, the distributive property says this means I could multiply 5 times each term that's in those parentheses. So this says to distribute the 5 means to multiply each term in the parentheses by 5. So that would give me 5 times 4 would be 20. 5 times 8 would be a positive 40. And then I add the two numbers, which would make it be 60. Okay. In previous problems, we've used the order of operations to simplify problems like this. Okay. Using the distributive property is just another method that we have for simplifying. And it's going to come in handy and be a lot more useful in the next section, 1.8, when we're simplifying algebraic expressions that have variables. Okay, so let's look at these two examples. I have the same problem that we had above. One is I'm going to work it out by order of operations, and the other one I'm going to work it out using the distributive property. Order of operations, remember, would tell me to do what's in the parentheses first. So I would bring the 5 down, and in parentheses 4 plus 8 would be 12. This means 5 times 12, which would be 60. Okay, so that would be my answer, worked out using order of operations. Same problem with the distributive property, like I did above, means I would multiply 5 times 4 plus 5 times 8. Okay, and I like to draw arrows, so I would say an arrow to the 4 means 5 times 4. And then an arrow to the 8 would be 5 times 8. So when I multiply that, it would give me 20 plus 40, which is 60. So we get the same answer either way. Okay, now typically if I had this problem, I would probably do this one by order of operations, like this. But now if we have variables, like the examples I'm about to show you, you're going to need the distributive property. So these examples are going to say, use the distributive property to write each expression without parentheses, then simplify the result. Okay, so because I don't know, number 1, 4 times x plus 2, because I don't know what x is, I can't add x plus 2. But I can distribute the 4, which will help me clear these parentheses, and that's what we're going to use the distributive property for the most, getting rid of parentheses. So 4 times x would be 4x. 4 times 2 would be a positive 8. Okay, and notice how I'm saying, well, these are both positive, so it's going to be a positive 8. I cannot add 4x plus 8 together any further because one has a variable, one doesn't. So this is my answer. This is as far as I can simplify. Okay, number 2, we have negative 6 times negative 5 plus 2y. So this time I'm distributing a negative 6 times a negative 5. We've got to use our sign rules here. When I'm multiplying two negatives, that's going to be a positive 30. So I just don't put a sign in front of the 30. That means it's positive. Then negative 6 times a positive 2y. Negative times a positive will be a negative 12y. And so again, I can't simplify any further because one has a variable, one does not. So this would be my answer. Number 3, you just see a negative sign in front of the parentheses. You can look at this two ways. You can look at it as saying this means the opposite of what's in parentheses, or it's the same thing if I would have a negative 1 in front of the parentheses that I would have to distribute. What's going to happen if I distribute a negative 1? Negative 1 times 2x would be negative 2x. Negative 1 times negative 7 would be a positive 7. So my answer would be negative 2x plus 7. Same thing I would get if I just changed the signs of these two. Okay, but if it helps, you can write out that this really means it's like there's a negative 1 that's understood to be in front of the parentheses. Okay, number 4, we have 8 times 3x plus 2 in parentheses plus 5. Okay, order of operations still means I have to clear my parentheses first, distribute the 8. 8 times 3x will be 24x. 8 times a positive 2 will be a positive 16. But I do not multiply 8 times 5 because that 5 is not in parentheses with the other terms. So I would just carry down plus 5. Then you need to look at your problems and say, are there anything that I can put together? So because I have these two numbers, I would need to go ahead and combine and make this be 24x plus 21. 16 plus 5 would give me 21. And now this is as far as we could take this problem. Okay, so this is called using the distributive property, and you will see this again, like I said, in future problems and future chapters that we're going to be working through.